Hey, yo, 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 yo. Hey, guys. So, thank you for tuning in. How do I get rid of this thing? Let's try that. Okay. So, thanks for tuning in. We're going to talk about piecewise functions. Last video of the quarter. So, here's your definition for piecewise. I just want to get into it. Piecewise functions are basically when we have certain intervals of our domain of a certain graph. So let's get into that right now so you can see what I'm talking about. So first, let's look at our absolute value function. And we're going to talk about how this is related to a linear function. And then that'll show us how we can define it as a piecewise function. So absolute value, we know we have two different lines here, right? We have, and this is why it's like a linear function. We have our left side, which has a negative slope. We have our right side that has a positive slope. So the way that this is a linear function, if I were to look at just this section of the line, the left side, and I wrote this left side as a linear function, this side has a y-intercept of 0 and a slope of -2. So this side would just be y equals -2x. That would be the equation for this line. The right side, very similar, but the right side is a positive slope, and so this side would be y equals +2x. Still has a y-intercept of 0. The problem is this, if I were actually really to graph y equals 2x, it would go on forever this way. Well, it stops at a certain point. So what that means is for a linear function, or for this to be related to a linear function, we have negative slope and a positive slope, but if I wanted to write it as a linear function, I could, but then I would have to define the domain for each section. So if I look here though, this is y equals 2x, but it's only when x is positive, right? When x is negative, that part of this graph doesn't exist. So that means that there's limitations to my domain for this graph of y equals 2x for this absolute value function. The domain is all the x values that are greater than or equal to 0. Because I'm not showing the other part of this where all my negative x values, because it ends right here at 0. Same thing for the left side. The left side is y equals -2x, but it's only for one section of the domain. It's only for all the negative x values. So that's when x is less than or equal to 0. So this right here is actually a piecewise function. This is a piecewise function of two linear equations that make this exact absolute value graph. So let's look at some other examples to kind of take it to show you what I'm talking about here. So here's a piecewise function. So I have f of x equals x plus 1, and that's a comma, with a domain of x is less than or equal to 2. And then I also have a second equation, -3/2 x plus 6, with the domain of x is greater than 2. So I'm going to graph just this one in purple right here. So x plus 1. So let's graph x plus 1 just like we always have graphed x plus 1. So it's a y-intercept of 1, slope of 1 over 1. So this would be x plus 1. And it goes in both directions. I can connect those points. I kind of missed, but you get the general idea. Okay. Now, so I'm doing this one in purple. But it's saying that I only want to see this section of the graph for all that domain values of x is less than or equal to 2. Well, here's 2, and I want all the values that are less than. So really what I'm doing is I'm erasing anything that's greater than 2. I just don't want to see that section of the graph. I only want to see the section of this line that is less than or equal to 2. So therefore I can put a closed circle. Well, my line was off. The point was actually correct. There we go. So because it's less than or equal to, I stop it wherever my graph is at x is 2. I show all the domain of less than 2. I'm using a closed circle because of the or equal to, just like we always have. So this is the graph x plus 1, but then I'm only showing it for the section that's x, for the domain that's x is less than or equal to 2. So really we're graphing our line the way we've always graphed, but then we are taking away part of it. Let's look at this one. +6 is my y-intercept. -3/2. 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. So that's this graph right here. Okay, but now let's look at what domain it wants me to look at. Well, it only wants me to see the values of x is greater than -2. Well, for the values that are x is greater than -2, well, greater than 2, 2 is right here. So what it's asking me is to only show the values that are greater than 2, so everything to the right of 2 on my graph. So everything to the left of it's not part of it. So this doesn't count. And that would be an open circle on 2. So the orange circle would be open, the purple one would be closed because it's greater than. Now, because they're overlapping, it's just going to show a filled-in circle at the end of the day, especially when you're doing it in pencil. You can't have different colors. So it's really just going to look like this, but one of them is less than or equal to, one of them is greater than, because we don't want 2 to be included in both graphs. And I'm done. So I graphed this on its own, I graphed this on its own, and I just erased the section of the domain. Try this one on your own. Really, just try it on your own, see how you do. So pause it, try it. Okay, so I have x minus 2, start at -2, positive x. But it's only asking me for less than or equal to 1. So I'm going to stop here at 1. I could go on and erase, but I'm just going to stop here at 1, and it just wants the values that are less than or equal to 1. Well, I'm going to stop at 1. It goes on forever to the left because it's less than or equal to. Oh, there's my graph. I'm graphing just a piece of this graph. All right, for -2x plus 3, positive 3, -2 over 1, -2 over 1, -2 over 1. And it's for all the x values that are greater than 1. Well, looks like that is going this way, because those are all the values that are greater than 1. But now this is going to be an open circle because there's no or equal to. And the reason why we have to have one open and one closed is because if this was a closed circle, this is no longer defined as a function because the input of 1 has 2 different outputs. All right, for x is 1, I would have 1, and I would also have this. But if I put an open circle on one of them, that means the input of 1 is not included in this, right? And then that means that for everything to the right of 1 is this, and everything to the left of 1 is this or this. So that's why we have to have one has to have an open, one has to have a closed circle. And we just follow our inequality symbols for that. Okay, so I just graphed a piece of it, and my domain was greater than 1, so I went to the right. So if I wanted to express the absolute value function as a piecewise defined function, we've kind of already done that with our first one, so see if you can do this on your own. The one thing that we didn't do in our first one that I want to include, because I was just trying to explain to you what it looked like, is one of these has to be greater than without the or equal to symbol to show that it's still a function. So go ahead and pause it, try it on your own, see how you do. Okay, so again, -3 absolute value of x, our vertex is 0, slope is -3 over 1, so it's going to really look like this, right? But here on this left side, I have this is a positive slope right here, right? Because it's actually going up. That's a positive slope. So we're going to have the left side be the or equal to, where it's less than or equal to, not greater than. Okay, and that is for the equation of y equals 3x. And then there's my domain. And my domain, I'm sorry, hopefully I didn't just super confuse you because I was writing the equation and the domain at the same time. That should be x values are less than or equal to 0. I'll say yes, Mr. G, shame on you. So x is less than or equal to 0, and my equation is y equals 3x because that's a y-intercept of 0 and a slope of positive 3. Okay, 1, 2, 3. Now, this right side, well, that's going to be y equals -3x, and that's for all the values that are greater than 0. And again, I had to do greater than because if I did greater than or equal to, I'm including 0 in 2 different functions. We can't do that because now that wouldn't work. Okay, and so we're done. Let's see here. I do have an independent practice for you. Okay, so this is a word problem that is going to have 3 different piecewise functions. So we have 2x plus 20, I have 1x plus 10, and I have 0.50x, and then there's no shipping fee. So those are my equations, right? $20 shipping fee one time. So here's my equation, $2 for each wristband. 1x plus 10 And then if you buy 100 wristbands, that's 50 cents each plus free shipping. Now this is kind of how buying in bulk works. A lot of times some things when you buy in bulk, it's a lot cheaper when you buy in bulk. So I only pay 50 cents per wristband if I buy over 100. If you buy 51 to 100 wristbands, you pay $1 each. And if I buy 0 to 50 wristbands, it's 2x plus 20. I want to see if you guys can graph these three in here as your domain. Graph them all on the same coordinate plane. So go ahead and pause it, try it, see how you do. Okay, so here's how I label my graph. I wanted to count by tens, okay? So really what I need to do is I need to graph for my domain from 0 to 50. So here's the number of wristbands, here's my cost. Well, from 0 to 50, so that's from here to here, is going to be, we'll do this one in red. Well, it's $2 each plus $20 for shipping. So my y-intercept is at $20. Okay. And then it is $2 each. So my slope is 2 over 1. Well, since I'm counting by 10, I actually can go up 2 over 1 because I'm going up 20 over 10. That's 2 over 1. 20 over 1. And I'm going to do this all the way until I get to 50. Okay. So this is for all the way up to 50, so I'm going to be up here. So that's going to show my cost. But then it's going to end here. Okay, so that's why I'm going to have a closed circle there at the end. Because that's from 0 to 50 wristbands. Well then, from 51 to 100, well I'm going to have an open circle on 51. I need to figure out, well, how much is 51 wristbands going to cost? Well, there's my equation. If I plug in 51 into this equation, my y-intercept was 10. But if I plug in 51 times 1 is 51. So that's going to be $61. So I'm right here. And I'm going to have an open circle at $60. Because if I plug in 50, shows where it starts really. Open circle because I can't include these. Okay, and then everything more than 51 or 50, so 50 was at 60 because 50 at $1 each plus the $10 shipping is $60. But I'm putting an open circle there because we're not really looking for 50, we're looking for 51. So this isn't included, but everything further to the right will. And now I can use my slope. That's going to be up 1 over 1. And then we're going to keep going until the end of our domain, which is going to be at 100 wristbands. Like so. Closed circle. So this shows me all my potential costs if I buy from 51 to 100 wristbands. And then for over 100, I need to figure out, well, at 100 wristbands, it's going to be $50 total. We'll do this one in orange. At 100 wristbands, it's going to be $50 total. So that's an open circle, 50 cents each, so it's at only half. And then it's going to be this way. So this shows me all my potential costs based on how many wristbands I buy. Okay, independent practice, good luck, do your best. If you have any questions, let me know. Credias out.